Okay. Assalamualaikum and good evening. Alright, so today I will do some exercise. Okay, we will do some exercise. I will show you some exercise. I will show you some exercise regarding the entropy change of pure substance. So let's look at this question. Okay, where a well-insulated rigid tank contains 2 kg of saturated liquid vapor mixture of water at 100 kPa. Initially, 3/4 of the mass is in the liquid phase. An electric resistor heater placed in the tank is now turned on and kept on until all the liquid in the tank is vaporized. Okay, determine the entropy change of the steam during this process. Okay, so you have two different states. Okay, the first state is saturated liquid vapor mixture, and the second state is vaporized, means that it is saturated vapor. So you need to find the entropy change, means the first thing you need to find is entropy at state 1 and also entropy at state 2. Okay, let's look at the state 1. Okay, the same thing, how you want to solve this. Okay, you have state 1, okay, and state 2. You must list down, okay, all the properties at state 1 and all the properties at state 2. Okay, for the state 1 is 100 kPa. Okay, saturated liquid vapor mixture, right? And also it said that initially 3/4 of the mass is in liquid phase. So 3/4 of the mass in liquid phase. Saturated liquid vapor mixture 100 kPa. So 3/4 of the mass in liquid phase mean the vapor, okay, M vapor is actually 1/4 from 2 kg. Okay, there's a 2 kg, right? From 2 kg. So it should be 2/4, 0.5 kg. Okay, so the second state is an electric resistor. So we know that for rigid tank, okay, well insulated rigid tank, okay, so for rigid tank, okay, the properties, the volume is constant. Okay, constant. Since it is closed system, mass is constant, so therefore specific volume is constant. Okay, constant, right? So volume, specific volume means that specific volume 1 is equal to specific volume 2. Okay, so you need to find 1, so you get 2. Okay, and it said that all the liquid in tanks vaporize, mean it become a saturated liquid. Saturated vapor, right? So to get the S, so you need to have S1 and also V1, okay, at 1, and also you get to you need to calculate the S2. Okay, so first we find the S1. Okay, to get the S1, since it's saturated liquid vapor mixture, you need to find the quality. Okay, calculate the quality. Okay, quality can be calculated using the X is mass of vapor divided by mass of total, which is mass of vapor is actually 1/4 mass total, right? Or you can say that this one is 1/4 M total divided by M total, you got 0.25. Okay, the quality. Okay, then you can find the S1. S1 is SF plus X SFG. Okay, value of SF and SFG you need to take at 100 kilopascal. Okay, 100 kPa. The same thing as V1. Okay, VF plus X VFG. So VFG is taken at 100 kPa. Okay, so I will open the properties table. Okay, since it is water. Okay, So saturated water 100 kPa. Okay, the value of first of all S is 1 point, okay, you got there, 100, okay, 1.303028, 1.3028, and SFG is 6.0562, while VF is 0.001043, and VFG is 1.6941. Oh, sorry. 1.6941 minus 0.001043. Okay, so you get the value there, calculated it. Okay, so 0.001043. Okay, you got 1.693057. Okay, put it in this equation, okay, for S. So you got S1 is 2.8168 and V1 is actually 0.4243. Okay, 43. This is kilojoule over kilogram Kelvin. This is meter cube over kilogram. Right? So that is your S1. So at state 2, okay, since V1 equal V2 equal to 0.4243 meter cube per kg. So you need to go to the saturated vapor, okay, saturated vapor, any value, okay, I show you how. So you go to the saturated vapor. So starting from, you can either use saturated water pressure table, or you can use saturated water temperature table. It's either one. So you got to C and the SG. The value must be 0.4243. So this is 7, okay, so many, okay, 6, right? SG should be, SG should be 2.81 VG, VG, not SG, VG. So you got to see VG. VG is 0.4. Okay, see there? 0.42431. Alhamdulillah. So that is in between, right? Okay, so this is the value in between 145 and 150. So you want to find the S value, which is here and here. Okay, that is the S value. Okay, S value should be SG lah, because V is VG. So 6.8827. Okay, so you will have like this, right? This is V, this is S. Okay, 3 things. Okay, so you have 6.8827, 0.8827, 6.8371. Okay, the V 0.446, 0.4460. Okay, 0.39248, 0.39248. And your V is 0.4243. Okay, so this is S2. Okay, do the interpolation. S2 minus 6.8827 divide by 6.8371 minus 6.8827 equal to, okay, 0.4243 minus 0.4460 divide by 0.39248 minus 0.4460. So you got your S2 will be 6.8649. Okay, right, 6.8649 kilojoule per kg Kelvin. Okay, so the entropy change is means that bigger entropy, not specific entropy. So it will be M S2 minus S1. M is 2 kg, S2 is 6.8649, S1 is 2.8168. Okay, then okay, calculate this. You got 1.80 8.10 kilojoule per Kelvin. Okay, so this is example of finding the entropy changes for substance, pure substance. Okay, water, in this case is water.